Good morning, good morning, good morning, good students. Today we are going to quickly resume from where we left yesterday. Remember, we are still busy by revising the question paper that was written in October, November 2023. And remember, this is O-level mathematics, syllabus D, code 4024. And currently, we are revising the paper one. Yesterday, we looked at matrices. There's a lot of things that we have covered as far as matrices are concerned. Remember, a matrix is basically an arrangement of elements in rows and columns enclosed by brackets. So, the best way to describe the matrix is to specify its order, whether it's a 2 by 2 matrix or it's a 2 by 7 matrix. What does that mean when you say it's a 2 by 7 matrix? It simply means that there are 2 rows and 7 columns. We've also seen how we add and subtract matrices, and this can only be done if matrices are of the same order. So if they are of the same order, you simply add or subtract the corresponding elements. We've also seen how we multiply matrices. The condition for multiplying matrices is now a bit different. But if matrices are of the same order, yes, you can multiply them. But you can also even multiply them even if they are not of the same order. But you now need to make sure that the rows of the second matrix are equivalent to the columns of the first matrix. These are some of the things that we've explored yesterday. If you have any query, let me know as far as that chapter. But I was very happy with the contribution that all of you guys you were doing yesterday. So far so good. We know that as far as matrices are concerned, we are all sorted. And trust me, this one is an interesting topic, and examiners they love to examine this topic a lot in the final exams. So let's quickly extend our understanding, moving on to question number 21. What do we have here on question number 21? The first question is written, factorize 6a minus 9. Even part B is about factorization, and part C. Wow, what an interesting question. Just imagine, in paper 1, we have about 5 marks just for factorization. Wow, wow. This is quite interesting. Anyway, let's take a closer look at this first question. Factorize 6a minus 9. All right, what do we mean by factorization? Imagine if I say factorize 8. What does that mean if I say factorize 8? In other words, we're trying to say which numbers that you can multiply to give 8. What are the factors of 8? What are the factors of 8 that multiply to give 8? So in this case, you can see that you can think, okay, the factors of 8 is 4 and 2. So 4 times 2 are the factors of 8, are the numbers that multiply to give 8. But if we say 8 is the same as 4 times 2, we can even say this is not factorized fully. Why? Because 4 can also be factorized further. So what can we do? We can say 4 now is the same as 2 times 2 times now 2. So 4 is the same as 2 times 2 and times that 2. Now if you say 2 times 2 times 2, you still get 8. And in this case, we can say we have factorized 8 completely. So just to factorize is basically to find the factors that multiply together to give that number. But in other words, again, remember factorization, when it comes to algebraic expressions, we can also define factorization as the opposite of removing brackets. Imagine if I've got a number like 2x that is multiplying a number like 4x minus 3. If I remove brackets here using the distributive property, if I say 2 times 4x, you know what I'll get? I'll get 8x squared. What if I say 2x times minus 3? I'll get minus 6x. So look at this expression that I have. So I can even say now factorize 8x squared minus 6x. So for you to factorize 8x squared minus 6x, by the end of the day, the answer will be 2x open brackets 4x minus 3. So this is what we get if we factorize 8x squared minus 6x. So in other words, factorization is basically the opposite of removing brackets, or the reverse of removing brackets, of expanding brackets. So let's see how do we exactly factorize algebraic expressions. Okay, let's take a closer look at this question. So we have a term 6a here. We also have a term minus 9 here. So we want to factorize these two these two terms, right? We want to factorize this expression. Remember, an expression is a collection of terms. Here we've got two terms, and the name that is given to an expression with two terms is a binomial. So here we've got a binomial. Okay, so we've got 6a and minus 9. So when we are factorizing, the first thing that we have to check is to check if there is a highest common factor. What do I mean by a highest common factor? A highest common factor is a number that can get into these terms. The biggest number that can get the biggest term, in other words, that can get into these terms without leaving a remainder. I know it's a bit confusing because there are terms that involves variables. There's also a term that is a constant. But whenever you are looking for a highest common factor, let me put another example which is a bit complex than this one. Imagine you've got 12x squared y cubed minus 9x to the power 4 y to the power of 6, right? And we want to factorize this. So obviously, you have to check um, the highest common factor of 12x squared y cubed and the minus 9x to the power 4 y to the power 6. In other words, you have to look for that biggest number that can get into these two terms without leaving a remainder. Remember, that number is a bit hectic because we have some variables and all the other stuff, but make it so simple. Focus at one situation at a given time. Check what is the highest common factor first of 9 and 12. So in this case, check the highest common factor of 9 and 12, of minus 9 and 12. Which number can get into 12 and minus 9 without leaving a remainder? You say that is 3, because 3 is the highest number that can get into 12 and also into minus 9. You can also check that one with your calculator for the highest common factor. You will get the answer. All right, and then after that, you go to the variable x, right? So here we've got x squared, here we have got x to the power 4. So what is the highest common factor of x squared and x to the power 4? You realize that it's x squared. So here on the variables, you pick that variable with the least power, with the smallest power. Here we've got x to the power of 2, here we've got x to the power 4. So 2 is smaller than 4, so we take x squared. You can also check here on y to the power of 3. Here we've got y to the power of 6. So the one with the least power is a y to the power of 3. And then you open brackets. This means that 3x squared y cubed is the biggest number that can get into 12x squared y cubed and into minus 9x to the power of 4 and y to the power of minus 9x to the power of 4 y to the power of 6. So now let's see how many times do 3x squared y cubed get into these terms? So let's start. So 3x squared y cubed into the first term. So 3 into 12 is going to be 4. X squared into x squared cancels. Y cubed and y cubed cancels. Then you go to minus. So 3 into minus 9, we get minus 3. And then x squared into x to the power of 4, we get x squared. Y cubed into y to the power of 6, we get y to the power of 3. So this will be our solution. So as you see here, if you want to verify to see if your answer is correct, try to remove brackets. Try to say 3x squared y cubed times 4. You get this one. If you say 3x squared y cubed minus times minus 3x squared y cubed, you get this one. So indeed, this is our solution. Okay, so guys, I want you to understand this chapter. Now let's go back again to the question at hand. So here we need to check the highest common factor of 6a and minus 9. A biggest number that can get into 6 and 9 straight away is 3. As you see here, we've got a. Here we don't have a, so a is not a common factor. So let's open the bracket. So 3 into 6a, straight away we get 2a. 3 into minus 9, we get minus 3. So yes, this is our solution. 3, open brackets, 2a minus 3. If you try to remove brackets, you go and get back again. This answer say 3 times 2a, you get 6a. So 3 times minus 3, you get minus 9. So indeed, this is an interesting question. Imagine you can even verify to see if your answer is correct. This is amazing. Let's quickly look at part B. Part B is written again, factorize 4b squared minus 25. How are we going to factorize this? This is quite interesting. Again, let's check if there is a highest common factor. Is there a biggest number that can get into 4b squared and minus 25 without leaving a remainder? Oh, let's check. Is there a number that can get into 4 and 25? Oh, no. Even if you try to check onto your calculator, you see the highest common factor of 4 and minus 25 is just minus 1. So, in that case, we can't say we don't consider 1 as the highest common factor when you are dealing with factorization. So, and you see there's a b squared here and there's no b squared. So again, b squared is not a common factor. So we've got two terms without a highest common factor, except just one. So what are we going to do? So if you see two terms without a highest common factor, especially at ordinary level, O-level mathematics syllabus D, if you see two terms without a highest common factor, know that you are dealing with a dots, with a difference of two squares. So how do we deal with dots? Remember in class we've said if we are factorizing expression of the form ax squared minus b squared, this is a difference of two squares. A squared is a square number, b squared is a square number. But remember what exactly a square number is. A square number is the result that you get when you multiply an integer by itself. So think of say, if you say 1 times 1, you get 1. If you say 2 times 2, you get 4. 3 times 3, you get 9. 4 times 4, you get 16. 5 times 5, you get 25. 6 times 6, you get 36. 7 times 7, you get 49. 64, 81, 100, 121, etc. So you can find out that these are what we call square numbers. So you can also even multiply unknown numbers and they can still give you square numbers, like a number that you don't know times a number that you don't know. You get a number that you don't know squared. If you say maybe the number that you don't know is j, and if you say that number that you don't know j times j, you can still get j squared. So we can also say numbers like a squared and j squared are also square numbers. And if you combine the normal square numbers that you know, like 49, together with a squared, you still get a square number, because a number that was multiplied by itself to give 49a squared is basically 7a. Remember, if you say 7a times 7a, you get 49a squared. So yes, we have a difference of two squares. 4b squared here is a square number. 25 here is a square number. So we are saying a square number minus another square number. So yes, it is a difference of two squares. So if it is a difference of two squares, what are we going to do? The solution is so simple and very, very interesting. So what are we going to do to this one? What we are going to do here, we are going to open two brackets, right? The other one we put a plus at the center, the other one we put a minus at the center. And then we ask ourselves a fundamental question, two fundamental questions. Which number that was multiplied by itself to give 4b squared? You see that is 2b. Because remember, if you say 2b times 2b, you get 4b squared. Okay. And you ask yourself again another second question. Which number that was multiplied by itself to give 25? You see that number is 5. Remember, if you say 5 times 5, you get 20. So yes, this is our solution, 2b plus 5 and also 2b minus 5. So this is our final solution. Let's quickly move on to the last question. The last question looks a bit interesting. They say simplify 2c squared minus 8c all over 2c squared minus 5c minus 12. I've seen